Okay, in this video we're going to look at limits using tables, and I'm going to show you how to do this on a TI-84 calculator so you can remember what buttons to push when we're doing a limit using tables. All right, so the problem we're going to look at is right here, limit as x approaches 1 of this kind of messy looking function. And the first thing that I would notice is that I cannot just plug in x equals 1 because that makes the denominator 0, and so that's actually why we care about limits. All right, so we're actually just going to do the limit as x approaches 1 from the left and the limit as x approaches 1 from the right so that we can look at each of these, and then the question is, are they the same? So even if they don't ask you to do separate one-sided limits, you want to make sure that you actually do each separate limit. All right, so for this first one, I'm going to be plugging in numbers that are just a little bit bigger than 1. So I'm going to think about plugging in numbers like 1.1, 1.01, 1.001. So you'll notice here that the way I set up this table, these numbers are getting closer and closer and closer to 1, but they're all just a little bit bigger than 1. So what I want to see in the table here is the progression of these numbers getting closer and closer and closer to 1, but they're all bigger than 1. Right? So I could have picked different numbers there, but I want the numbers that I picked to be closer and closer and closer to 1 and all bigger than 1. And then I'm going to find the y values. And then I'll do a similar table where x is approaching 1 from the other side at the bottom here. So, okay, so the first thing that I'm going to do when I do this on my calculator is I'm going to go into y equals. And if you have a function already in there, then clear that out. And you're going to just type in the function that we're working with here. So I do have to be careful when I type this one in to put parentheses around the entire numerator and parentheses around the entire denominator. Otherwise, it will just take the last thing divided by whatever the first thing is that you've typed there. So I'm going to use my parentheses key here. And then I'm going to just type x plus. And then my square root key is right here. It's a second square root of x. Some calculators, you actually have to, it'll insert another parentheses right there, and you actually have to close it. I don't have that model of calculator. But I do have this little arrow here, which is telling me that if I'm not careful, what I type next is going to be inside that radical. So I want to use that arrow to get outside of that radical. So notice my -2 here is not inside the square root. -2, close that parentheses, and then divided by, and then I'm going to type this denominator. And then again, I need to get out of that radical, so I'm going to use my right arrow key to get out of the radical, or if you have parentheses there, you close the parentheses around whatever's inside the radical, and then -1. Be sure you're typing subtract instead of the negative key there for the 2 subtractions that I have, and close my parentheses. All right, so if I wanted to graph it, I could go ahead and graph it, but we're actually going to use the table. So we're going to do that. And because I have some specific values that I want to plug in for x, I'm going to have to make sure I have the calculator set up so that it allows me to do that. So before I go to the table, I'm going to go to table set. So that's second, and then my second key up here at the top is window, table set. And so there's a bunch of different choices here, but basically what you want to change is this independent variable, that's your input variable, or x variable, to ask. So that's where it will allow you to type your own value. So I just use my arrow keys here to go down to where auto was highlighted, and then I'm going to go over to the right where it says ask, and I'm going to press enter. And so that's really the only thing I needed to change. Whatever these other things are at, it doesn't really matter. You want that independent variable to be on ask. All right, and then if I go to table, so second graph will take me to the table. See a table here, and you can type whatever values you want in for x. So I'm just typing in 1.1, and then 1.01, and 1.001. And you can see over here on the right, there are some values. I know they're very tiny, perhaps, so I highlighted them so you can see a little bit better here. But the other thing I wanted to point out is that when it fills up this table, it truncates those digits. in that decimal. So if you want to see more, you can just use your arrow keys to go over and highlight those y values, and you'll see a lot more decimal digits down here at the bottom. So I'm going to go ahead and write these down, 3.04. I'm not going to write all the digits my calculator has here, but I'll just write a few here. And then the next one, up in the table it says 3.005, but when you highlight that, you can see that it's actually 3.0049875. I'll go ahead and just round there to another decimal place here. And then one more down here. So up in the table it says 3.0005, but when I highlight it, I see some more accuracy with those digits there. All right, so it appears that what's happening is that these values are all getting closer and closer and closer to 3. Perhaps I want to type in some more numbers and verify that that really is what's happening. One of the disadvantages of tables as opposed to other things is that you've really only got however many values you typed into the table. But these values appear to be approaching 3. So I'm going to put here that I think this limit is 3. All right, and then we're going to do the same thing here where I let x approach 1, but from the left. So I want these numbers to be a little bit smaller than 1. So you might think about just visualizing a number line and just thinking about if you're at 1 and you just go a little bit left, what would be a decimal number that you would be that? Maybe 0.9. And then closer, 0.99 and 0.999. Right, so again, really what I want to see is the progression here, that these numbers are getting closer and closer and closer to 1, but they're all a little bit left of 1. So you could pick different values, but whatever you pick, you want to start out pretty close to 1 and then get closer and closer and closer. Sometimes students will start with something like 0, thinking about 0 being close to 1, but that's not really close enough to 1 for you to really see what's happening here. So you want to start out very close to 1 and then get even closer, but staying on the left side. All right, and since I already have my function in the y equals and I've already set up my table, I can just go ahead and kind of add to the table that I've got here and type these new values in. And you can just keep scrolling down if you need more values here, but I'm just going to do these 3. All right, so when x is 0.9, the y value, we got 2.94868. If you look down here at the bottom, you see a few more digits of accuracy. And then the next one, it says 2.995 up in the table, but if you highlight that, you see more digits, 2.994987, and then one more here, 2.999499987, and some other digits. But these values all appear to be getting closer to 3 also. So these also appear to be getting close to 3, and since these two agree, these two one-sided limits agree, we can say then that the overall limit as x approaches 1, the double-sided limit of the original function, which is what it asked at the very beginning, that this limit is 3 also, since the two one-sided limits agree. All right, so you could look at the graph as well to verify that, but often the table is a little bit easier. It's sometimes hard to trace on the table and get really close to where you need to be. So table is often the best way to do that if you don't have a simple graph that you already know what the graph looks like.